Welcome back to Information Systems and Cybersecurity 375 as we continue our exploration of web design. Today we're going to talk about two topics. First, we're going to talk about how a web browser, a client, and a server communicate using the Hypertext Transport Protocol, HTTP. And then we're going to talk about HTML5. And I'm going to introduce you to just a few of the basics of that language, the elements that you need to know to create a simple web page. So let's start by talking about HTTP. As I said, that stands for Hypertext Transport Protocol. I think we talked last time a little bit about what hypertext means. It's this idea that one document can link to another document. That is, that you can click on a link and navigate from one document to a different one. So Hypertext Transport Protocol was designed at the beginnings of the World Wide Web. It was designed for the web. And it was intended to be a lightweight and very simple protocol. Lightweight means that it doesn't use very many resources. So the web server doesn't have to do a lot of work to serve a web page. As long as it knows which page to find, it basically just uploads it to the client. And also, it doesn't use a lot of network traffic. So it doesn't send very many packets. It doesn't take up a lot of extra bandwidth for control messages. It's a very simple, straightforward protocol that doesn't use many resources. So it's actually really simple. The client, the web browser, will send a request to the server. And that request contains some information. In particular, it contains a method, a URL, and a version string. So that request is sent on a connection using TCP port 80. TCP is the Transmission Control Protocol. It's part of the Internet Protocol stack. And that message is sent just in plain text in English. You can read it. And that method string can be followed optionally by some headers. So for example, we could send the word get, which is a method, the URL /hello.html, and then the version http/1.1. And then we could provide the header host:/marmerstein.org. So that's what we have right here. And that's our request message. So very simple, plain text, easy to read, easy to understand for the most part. We'll talk about what some of these things mean in more detail in a bit. And then the server is going to send back a response. And that response might be, sorry, couldn't find your web page. Or it might be, OK, here's the web page. So the response also has three parts. It has a version and status part. It has a headers part. And then the body of the message contains the actual HTML if it was able to retrieve the content. Or if it was an image, the image file data would be in the body. So the version status part will have the HTTP version, and then it will also have a code, a status code. Now, status codes are hard for human beings to read. If I gave you a numeric code, 600, well, you wouldn't have any idea what 600 meant. You'd have to go look it up in some table. So the protocol is actually designed so that the web server sends two different status messages. One is a numeric code that's easy for the web browser to process that programs like to work with. Programs love working with numbers. But then it also sends a text string that a human being can read so we know what the number means. So for example, if the web server is able to find the page and it's fine, it's there, and it's able to send it, then it'll send a status code of 200, which means OK. So it'll say 200 OK. The 200 is for a web browser like Firefox to use. The OK is for a human being like me. If I'm trying to figure out why something's broken, I can look at the server traffic and see that, OK, it wasn't a problem on the server. Some of the other status messages that are important are status 301, which means moved permanently. If I had a page that was at one URL, and I decide to rename it to something else, I might configure my server to return a 301 message if someone tries to access the old name. And most web browsers are pretty smart. They'll automatically redirect you to the new page, but they'll correct the URL so that you know that you're supposed to go to the new URL instead of the old one. Another error message that you've probably seen before is message 404, which means page not found. If you are trying to go to google.com and you put, I don't know, Gloogle in, it might actually correct it because Google has probably reserved Gloogle to avoid typo squatters. But if you type something incorrect and there's no page with that name, you'll get a 404 error with a page not found message. a status message that you probably haven't seen before and will probably see for the first time in this class is error 500, which means internal server error. This happens when you write a script to process some information that's coming from a web form, and there is an error in your script, some kind of programming bug. The server will run your script, and it'll crash or have some other issue, and the server will look at that and say, what do I do? It sends a 500 message back to the web browser. And Firefox or Chrome will say, error 500. So we have the version status part of the response. That's followed in the response by the headers. And it's really important that the web server send these headers because they provide the web browser with information about the page that's important for it to display correctly. For example, one of the headers is the content length. That tells the web browser how many bytes the web page is, so it knows how much data to expect. It also sends a content type, which identifies the file type of the page. So, for example, if you requested an image file, this might be a PNG or a JPEG or something. If you requested the HTML page, it would be text/HTML. Depending on the type of the resource, the content type will vary. There's various dates that are important and that can be sent as headers. The date of the request is often sent as the header, but also there's a last modified date that is usually sent when you request headers for a web page, and that allows the web browser to do caching. For example, if I go to marmerstein.org and download the page, my web browser probably doesn't want to download that page again because it's just downloaded it earlier this morning. And I haven't made any changes to marmerstein.org in the last few hours, so there's no point in downloading a second time and using all that network bandwidth and maybe some extra disk space. So what my browser will do is it'll look at that last modified date, and if the page hasn't changed since the last time it downloaded it, it'll just use the copy it already has in the cache. Another important header is the expires header. Some information is time sensitive, and if you put an expires header on it, the web browser knows to throw it away if it's out of date. For example, maybe you logged into your bank. We don't want you to be logged in forever because that's insecure. So there might be some sort of expiration header there, an expires header that says, after an hour, don't use the old username and password credentials. And then following the headers, we have the body of the message. As I said before, that contains the actual HTML or the image data. That's the actual content of the response, what we call the payload. So for example, a response might look like this. The version is HTTP 1.1, and the page was there, so we got a 200 OK status. That status and version information is followed by two headers in this example, a content type of text HTML, so this is a web page, an HTML web page, and a content length of 40 bytes. And those 40 bytes consist of this web page. There's an HTML tag, a body tag that says hello world, a slash body tag to say, okay, that's the end of the body, and then slash HTML to say that's the end of the web page. Now let's talk about HTTP in a little bit more detail. So we said before that when you make an HTTP request to the server, the request has three parts. It has a method, a URL, and a version. There are actually several methods that we could use. We saw the get method. The get method is the most common method used on the internet. The get method quickly and efficiently downloads a page. So it's a way to request a page. Another method that's commonly used is the head method. The head method only fetches the headers for the page. And the most important of those is the last modified header. This, again, is used for browser caching. If I want to know if the page is out of date or not, I send a head request to the server first. When the last modified date comes back, I can check it to see if I then need to do a get request or not. So this saves network bandwidth and conserves resources all around. A third method that's important is the post method. When you log into a website or fill out a web form and hit submit, the browser typically will use the post method to send the data to the server. Then the server will do some processing and create a web page, and that generated web page will be sent back as the response to the post request. So the post request does two things. It fetches a web page, but in order for the web server to generate that page, the browser first sends it information. So post both sends and receives information. Actually, the GET request can do that too, but GET request is limited to a very small amount of information. You can only send things that can be encoded in a URL, and that has a maximum length of 255 characters. The put and delete requests are not as important for web browsers like Firefox and Chrome, but they are important when you start writing applications that use what's called a REST API. The REST API is used for one program to talk to another program using HTTP. So this is HTTP, but it's not HTTP for the web. It's an internal communication that happens between parts of a program. For example, if I have a web application that wants to talk to a database, it might communicate with a database using HTTP, and it would use put and delete to implement parts of that API. URLs are uniform resource locators, and all that they do is uniquely identify a page or a document on the web. If you want to download a web page, your browser needs to know which web page. And it's really important that the name that you use is a unique identifier. The reason for that is that if two pages on the internet had the same name, your browser wouldn't know which one to fetch. You would put in yahoo.com and you would get something else because they both have the same name and the browser would have to guess. So part of the internet standard, part of the HTTP standard, is a system for creating unique names for resources. And the important part of that standard is this syntax. A URL consists of a protocol. For now, that's mostly going to be either HTTP or HTTPS. HTTP is the hypertext transport protocol we've talked about. HTTPS is a version of that designed for secure communication. And then a colon and a slash slash, followed by a domain. The domain identifies the server to contact. And then another slash, and following the slash is a path. And the path identifies the file on that server to fetch. Of course, a server may have many files, and those files might be organized into folders or directories. So we can actually specify several folder names separated by slashes as part of the path. Following the path, we can optionally put a question mark and a query string. That's used to specify things like keywords for searches. The HTTP version part of the request is actually the simplest part of that packet. It's either HTTP/1.1 or HTTP/2. There are older versions of HTTP, but they're not widely used. We're going to focus mostly on HTTP 1.1 in this class. HTTP 2 is new and it's becoming popular, but it's so similar to HTTP 1.1 that there's really no point in talking about the differences in this course. So an example of an HTTP request is get, that's the method, index.html, that's the path part of a URL, and then HTTP/1.1, which is the HTTP version. So I mentioned before there are two protocols, HTTP, which is unencrypted and insecure, but is very, very fast, and HTTPS, which is slower because it's encrypted. Now, encryption actually does two things for you. The first thing that encryption buys you is what we call verification. You can know for sure that the website that you're contacting is the one you meant to contact because HTTPS provides certificates, usually TLS or SSL certificates. TLS is transaction layer security. SSL is secure socket layer security. TLS is a newer version of SSL. So when a system administrator installs a TLS or SSL certificate on a server, that certificate is cryptographically signed, and your browser can verify that the certificate is the correct one. And that means that if you go to your bank, your browser will actually check and say, is that really the bank? And the bank will send back a certificate, and your browser can know with mathematical certainty, yes, I'm talking to the bank, and not to some hacker who's in between us pretending to be the bank. The other thing that HTTPS gives you is the ability to encrypt the information that's sent across the wire so that somebody can't intercept it. So if you're sending a password across the network, it's important to use HTTPS because you don't want someone to spy on you and read your password in plain text. I think I already mentioned that the domain uniquely identifies the server to contact. That's actually slightly misleading because domains actually map to IP addresses. And an address is just a number that identifies a server on a network. Although it's possible for servers to have multiple IP addresses and multiple domain names, that's a little bit beyond the scope of this course. One important thing is that domain names are read from left to right, and they go from more specific to less specific. So for example, the domain www.longwood.edu, edu is the least specific part of that domain. It represents all educational institutions. Longwood is a little bit more specific. It identifies a particular educational institution, and www identifies a particular server on Longwood's network, the World Wide Web server. So we call edu the top level domain, and there are a limited number of those. There's one for each country, and each organization type has one, nonprofits, networks, military, and so forth. I mentioned before that a URL can have an optional query string that's used to pass information to the web server. This can be done either in a GET request or in a POST request, but typically it's done with a GET request. Queries consist of key value pairs. So for example, I could say that the age is 30 and the name is Robert. The key value pairs are separated with an ampersand character, and they're separated from the path part of the domain with a question mark. So here's some example URLs: http://marmerstein.org/twiddle/robert/fall2016/is375.html. The protocol is HTTP. The domain is marmerstein.org. The path is twiddle/robert/fall2016/is375.html, and there is no query string. The second example, http://www.longwood.edu/search?q=name and v=bob, actually has a query string. So the protocol again is HTTP. The domain is www.longwood.edu. The path is just the page search. And the query string is q=name and v=bob. This actually comes from Longwood's web page. There's a little search bar that lets you search for faculty members by name. So if you search for Bob in that bar, this is the URL that it generates. And it gives you a list of all the people at Longwood whose first name is Bob. So here's a detailed example of how HTTP works. We connect using port 80, TCP port 80, to a server, in this case marmerstein.org. And then we send a request. In this case, I'm asking for headers, so I'm using a head request. The resource that I want is /, which is the default page, or that's usually the index.html page. And then the version I'm using is http:/1.1. I'm also going to specify a header. In this case, it's host, and I'm telling it the host is marmerstein.org. There's actually an interesting reason that I'm doing this. It's important to keep in mind that the same server can host multiple different websites, what we call virtual hosts. My server hosts marmerstein.org, but it also hosts a website for my church, stjohnsfarmville.org, and several other web pages for organizations I'm involved with. So in order to fetch a web page, we need to tell the server which of those virtual hosts we're talking to, and so we do that with this host header in the request. Then we hit enter a couple times, and the web server will spit back the status, 200 OK, it found the default page. The header information, the date, what type of server it was, it's an Apache server. The last modified date, apparently I haven't done this since June 19th, and I made this request in July, so hadn't changed in a while. The number of bytes and the type of the page. Notice that since this is a head request, it doesn't actually send me any HTML, so there's no data here. Let's talk now about HTML. HTML is a language that's used to describe the content of a page. So what is HTML? Well, it's a hypertext markup language, and hypertext was new in the 80s. It's a kind of document that allows you to include links to other documents. In this course, we're going to discuss HTML version 5, which is the newest version of the HTML standard. It was created by the W3C, the World Wide Web Consortium. It is radically different from previous versions of HTML, such as XHTML and HTML 4.01. In those versions of HTML, the W3C was trying to make the language strict. They wanted to put the burden for making sure that the page was properly formatted on the web developer. In HTML5, they have completely reversed course. Now it is the job of the web browser to properly parse the document. The web developer, the web programmer, doesn't have to be as careful. So the language is less strict. That means that if you make a mistake, if you have an opening tag and you forget a closing tag, or if you get some things out of order, the page will probably display at least partially. HTML5 also is much simpler than previous versions. They removed some tags that weren't heavily used and weren't really needed. And they added new tags to make certain tasks that before were complicated much easier. They added new multimedia support, such as a video tag, so that you can easily embed videos, and an audio tag for sound files. They also allow you now to draw to a canvas using JavaScript, and they added some tags for displaying graphics using SVG images. You can actually embed an SVG file directly in a web page to display it. And they also have better cross-browser support, which means that pages will look the same in different web browsers. So a key feature of HTML5 is that it's designed to do something very important, to enforce an important computer science principle. Windows has stopped working. Surprise, surprise. I'm a Linux guy, right? OK, the key principle is this, that you should separate content from presentation. And we're going to do that in this course by putting our content into HTML documents and our presentation into CSS files. So presentation is the look and feel of the web page. So we're not going to do a lot with color in HTML. That'll be in the CSS. If we want to change the color of something, we'll do that later with CSS. The purpose of HTML is to structure the content, to lay it out into different sections and organize it. So here is what a standard HTML web page will look like. When you create a new web page, these are the tags that you should put in right away. So the first thing that we're going to do, up way at the top, is put a doc type tag. This tells the web browser, Firefox, that the document that we're looking at is an HTML document, an HTML5 document. So every web page you create will start with a less than, a bang, doc type, the word HTML in lowercase, and then a greater than. By the way, in computer science, we call the exclamation point a bang. So angle bracket, bang, doc type HTML, angle bracket. By the way, angle brackets, or less thans and greater thans, are how we are going to identify tags within a document. We'll talk more about that in a minute. The next tag in this document is an HTML tag, HTML lang equals EN. This says the web page begins now and it's in English. Then we're going to have a head section identified by a head tag and a /head tag. The head tag is actually for header information, like the title of the page. And it's followed by the body section, body and /body. The rest of our web page is going to go there. Most of what we do in the web page is going to go between the body and /body tags. Finally, we close the page with a /HTML tag that says, the page is over, we're done now. So let's talk a little bit more about that head tag. The head tag gives us information about the page that isn't displayed in the body of the page. So for example, the title of the document that shows up in the operating system title bar or in the tab will be in the head section. Other information such as the character set can also appear there. So here's an example head section. We have the head tag to tell where the header section starts and a /head tag to show where it ends. And in between, we have a title tag that identifies the title. So the words, this appears in the title bar, would be our title. We can also include a meta tag that identifies the character set. Different languages have different alphabets. English has 26 letters. However, Chinese has hundreds of symbols, and if you want to display a Chinese page, you can't do it using ASCII text. So the HTML standard allows you to specify a character set to use. In the past, it was really important to pick exactly the right character set. However, recently, most web developers are moving to the UTF-8 character set, which is sort of a universal character set that has all the Latin letters we use in English, all the Chinese, Japanese, and Korean characters, as well as Cyrillic, Hebrew, even emoji are available in the UTF-8 character set. Later in the course, we're going to talk about a header tag. The head tag and the header tag sound a lot alike, but they are very different, and it's important to keep them straight. The header tag is used to identify a section of a web page usually a common section that's shared between multiple web pages and goes at the top. Something like a corporate logo might go in a header section. But the head section is used for information about the web page that doesn't go in the body. It's used for HTML headers, not for page headers. I realize that's confusing. Please do your best to keep them straight. I'll try to remind you when we get back to the header tag that it's not the same as the head tag. So here's an example web page. Again, notice we have doc type HTML at the very top. Below that, we have HTML lang equals en, so it knows it's English. We have head and /head to mark the head section. We have our character set in the meta tag. We have the words boring page for the title. And then in the body section, we have the rest of our page. It says this is an example page. It includes a single paragraph. Notice that throughout the text, we have other tags. We have angle bracket P, angle bracket, right under the body. P, by the way, stands for paragraph, so that's how we create a new paragraph in HTML. Look at the very bottom of the page, you'll see that there's a /body tag that says this is the end of the body, and underneath that a /HTML tag that says this is the end of the web page. You're going to have those in every page you create. So this page looks a little bit like this. So notice that the words boring page occur in the title. If I highlight it, you can see right here the words boring page occur. So HTML is actually made up of 3 different kinds of programming features. Entities, elements, and attributes. So what are entities? Well, there's 2 kinds of entities. Text is an entity, and there are also special character entities. Entities make up the content of the page. They make up the actual information that's displayed. So if you type a paragraph about something, that's an entity. It's a text entity. Elements are the tags in the page. And those elements identify different sections of the page and help us organize things. There are also some tags that change the behavior of the page. For example, the B tag listed here and the /B tag allow you to bold a section of text. You can say, OK, start bolding here and stop bolding there. So B starts bolding, /B stops bolding. The third aspect of a web page are what we call the attributes. Attributes are attached to an element. An element can have multiple attributes, and the attributes sort of configure that element. They change its behavior. So for example, we're going to learn that there's an image element, an IMG element, and that IMG element can take 2 attributes, a source attribute and an alt attribute. And here in this example, what we've done is we've said the source of the image, the source file, is banner.png, banner.ping. And so when the web browser sees this tag, it will load banner.png from the web server and embed it into the page. The alt attribute specifies alternate text to display if the image can't be displayed. We'll talk about why that's important later in the lecture. So the 2 most important elements are the A element and the image element. And we're going to talk first about the A element. The A stands for anchor, and it's how you create a link to another page. The A element actually takes 2 attributes that are really important to understand. The first one is the href attribute, which specifies the target URL of the link. If I click on a link, the web browser will know what page to load by looking at the href attribute. So the href, it can actually be a URL for a new page, or if I put a little number sign in front, it can be an anchor within the page. So for example, I can click on a link to scroll to the bottom, or click on a link to jump back to the top. The target attribute is very badly named. What the target attribute does is it tells the web browser how to open the page, whether it should open it up in a new tab or window, or whether it should load it in the same window, replacing the current text. So if you want it to open in the current window and replace the current page with a new one, you can set target to _self. That's also the default. If you omit the target attribute, that's what will happen. If you want the link to open in a new tab, you can say target equals _blank, and that will cause the web browser to open the link in a new tab or new window. So here are some example URLs. You can say go to top of page, and you can set href to $ top. And if you have an element that has the ID #top, then it will jump to the top element. We could say visit Google, and we could make Google a link to Google by creating an A tag with an href attribute of http://www.google.com. Notice that with the A tag, we have a /A tag. That will tell the web browser which things are part of the link. So in this case, we want just the word Google to be part of the link. So since the A tag comes before Google and the /A tag comes after Google, the web browser will know that only the word Google should take you to the Google web page. And then at the bottom, we have an example of how to open a page in a new tab. If you click on the words new tab, then marmorsney.org will open because of the href attribute, but it'll open in a new window or new tab because the target is _blank. The image tag takes two attributes, a source attribute that provides a URL to the location of the image file, and an alt attribute that provides an alternate representation in case you can't view the image. Why might you not be able to view the image? Well, users who are blind obviously can't read a web page, so we have devices and software that will do it for them that we call screen readers. And screen readers are really pretty good, but they have difficulty with images. If you provide alt text, the screen reader can read the alt text to the person with a disability so that they understand what information was being presented. If you don't specify an alt text, you're kind of being unfair to them. And keep in mind that the disabled represent a pretty significant market, and you don't want to just make your page inaccessible to them. Another reason to provide alt text is in case the image doesn't load properly. Someone who's reporting a bug about your website can say, okay, it's supposed to do this, but the image is broken. System administrators often use text-based web browsers that can only show the text of a page and not graphics. Why would we want to do that? Well, if we're logged into a system remotely, loading graphics is very slow. So using a text-based web browser is a lot faster and more efficient if we want to just look something up. So alt text is really important to have for that use. And finally, search engines obviously don't understand images. They can't read your image. So it's really important to give the search engine information about your page and what's in it so it knows how to properly index it, and people will be able to find you when they look for you in Google or Bing or Yahoo. So here is an example of an image tag. Notice that we put it in angle brackets to make it a tag. We start with IMG, which stands for image, and we have two attributes, a source attribute that says the URL is myimage.ping, and an alt attribute that says picture of a dog. Another thing to point out about this is that we use double quotes around picture of a dog. In this case, we had to do that because there were spaces in the alt text. When you want to group something together that has spaces, you need to put double quotes around it to make it one unit. If you don't have any spaces in your value, you can leave out the quotes, and that's fine. Here are some other important tags and elements that we might use in a web page. These are what I call style elements because they actually change the look of the page. So for example, we can bold something, we can put something in italics, we can emphasize something, we can use underlining. It used to be the case that you could put something in a teletype font. That still works. You can use the TT tag and the /TT tag to put something in teletype font, but it's discouraged. It's what we say, it's a deprecated tag. And it will probably go away in future versions of HTML. Instead, what you're supposed to do is use a more specific tag that identifies particular kinds of content. And there are several reasons you might want to put something in teletype. 4 of the most important are because it represents keyboard input, something the user is supposed to type, for instance, in a tutorial, or a mathematical variable, or some code that, for a program, or possibly output from a computer program. So those 4 are represented using the KBD tag, the var tag, the code tag, and the SAMP tag. So I mentioned before that entities are the part of HTML that allows you to provide content. And there are 2 kinds of entities. There's text entities, paragraphs and sentences, and there are also what we call special character entities. So text entities are characters of text. They're usually grouped together into blocks like a paragraph, and they're encoded in some sort of character set. We're going to use UTF-8 in this course. The special character entities, however, are also really important. Remember, we're using the less than and greater than signs to specify tags for our elements. And that means that if we actually want to show a less than or a greater than on a page, we can't do it by just saying less than or greater than. So in order to be able to represent special characters like that, we can use HTML special character entities. Special character entities start with an ampersand character and end with a semicolon. The ampersand is Shift 7 on your keyboard. It's actually really interesting historically. In some places in England, there's historical evidence that it was considered part of the alphabet. It was considered a 27th letter. Now it's just considered a punctuation mark, and it represents the word and. But in HTML, we use it to start a special character entity. So some examples of special character entities are the less than. To embed a less than in a document, you would write ampersand LT semicolon, and that would give you a less than character. To do greater than, ampersand GT semicolon. And some of the other things that you can do are listed here. An ampersand itself is ampersand AMP semicolon. One of the important special character entities is what's called a non-breaking space. Web browsers display pages on any kind of screen. And as a web developer, you don't know what your users are going to be using. They might be on a smartphone with a very tiny screen. They might be on a desktop system with a very wide screen, or even with two screens side by side. So you don't know if your page is going to look nice because the lines could be short or they could be really long. What's nice about this is that most web browsers will wrap lines for you to make your text fit the screen. Unfortunately, this can sometimes cause some odd behavior. For example, suppose you have a compound word like house pet. You don't want house and pet to wrap so that house is on one line and pet is on the other. One way that you can solve that is to put a non-breaking space between them. A non-breaking space looks just like a normal space, like you would hit spacebar, but it's not allowed to wrap to the next line. So you would say house ampersand NBSP semicolon pet with no spaces around the ampersand NBSP, and then the web browser would know to keep house and pet together. Another way to create special character entities is to use the entity number. There's a big table on the W3C website that lists all the numbers for every possible entity. And you can, for instance, get a less than by saying ampersand number sign 60 semicolon, because 60 is the number for a less than. We've talked a little bit about attributes for particular tags. There are also some global attributes that can be used with any element on your web page. One of those is the ID attribute. The ID attribute uniquely identifies an element. And that means that you are not allowed to create two different elements with the same ID. That will be useful later when we talk about CSS. Another way to identify elements on your page is to use the class attribute. That identifies a group of elements that should be treated similarly. Many different elements can share the same class, although they can't have the same ID. And also, an element can have multiple classes. It can belong to several different classes. Another global attribute is the language attribute that identifies the language of the document, if it's in the HTML tag, or of just one element. So for example, we've said HTML lang equals en and /HTML. That says the language of this entire page is English. I could have a paragraph tag, a p tag, and I could set its ID to intro. I can only have one intro paragraph if I do that, because ID attributes must be unique. I can only have one element with the ID intro. Or I could have a paragraph and say this is a copyright paragraph and set its class to copyright. If I do that, I can have other paragraphs that also have the copyright class. So in summary, HTTP, Hypertext Transport Protocol, is a request-response protocol that allows a client, a web browser, to communicate with a web server. We create web pages using HTML, which is a markup language that uses tags to identify related content and organize a page. HTML documents consist of three parts: entities, elements, and attributes. And also, we talked a little bit about why content and presentation should be kept separate. We want to do content in HTML, and we'll do presentation in CSS. Thank you for listening. See you next time.